This experiment is about burning of magnesium ribbon. It's the full ribbon and we have cut the ribbon into a small piece. This is a watch glass, and then we have blue litmus and red litmus paper, and then this is called as the tongue. Then we will hold the magnesium ribbon with the help of the tongue and adjust its setting, and then we will put it in the flame of the Bunsen burner and we will collect the ashes. And now as you can see, it burns very brightly, and it's advisable not to look at it directly because it will just cloud your vision. And then we will collect the white looking powder, which is the magnesium oxide, because magnesium plus oxygen gives magnesium oxide. And now we will pour some water and make it a solution, and now we will see whether magnesium oxide is acidic or basic. So first we will dip a blue litmus paper. As you can see, it doesn't change its color. But now when we dip the red litmus paper in it, then we will see gradually after some time it will change its color to blue. That means it's basic in nature. This experiment is about the precipitation reaction between lead nitrate and potassium iodide. First, we will take two test tubes in a test tube stand and add water in equal amounts. Next, we will take lead nitrate, which is a white color looking powder. We will collect it and add it to the first test tube and then mix it well to form a solution. The solution formed will be a little viscous and foamy type. Then we will take potassium iodide, we will collect it and add it to the second test tube and then mix it well to form solution. The solution of potassium iodide will be more transparent and clear as compared to lead nitrate. So here we have two solutions, one of lead nitrate looking a little foamy and next of potassium iodide looking transparent. Then we will add potassium iodide to lead nitrate and see if there is any change of color. We will observe that as soon as we add potassium iodide to lead nitrate, a gorgeous yellow color will be formed because of the precipitation reaction. The precipitate hence formed is of lead iodide alongside the formation of potassium nitrate. Precipitate is something that is insoluble in water, so after some time we will see that it will be settled down at the bottom of the test tube and the supernatant will be separated from it. It's also an example of double displacement reaction. This experiment is about reaction between zinc and hydrochloric acid. First, we will collect some of the zinc metal granules. Zinc is found as crystals and the color is grayish. We will collect some of the crystals in a watch glass. Then we will transfer it to a beaker so that we can observe it in a better way. And then we will pour some hydrochloric acid. Hydrochloric acid that is found in the laboratory is in a very diluted condition, so it's not that much explosive, but still we have to be very cautious while handling it. We will collect some of the hydrochloric acid in a dropper and then we will pour it in the beaker. As soon as the acid touches the zinc crystal, the reaction will start. The white color gas that is coming out, as you can see now, is of hydrogen gas because Zn plus HCl gives ZnCl2 plus H2, and if you touch the bottom of the beaker, you will find heat coming out because it's an exothermic reaction. We can also do the experiment in another setup using a conical flask and a stopper. This experiment is about the reaction of calcium oxide with water. First we will take calcium oxide, also called as quicklime. Here we have it in its powdered form and is white in color. We will collect some of the calcium oxide in a beaker using a spatula. After collecting a considerable amount, we will add water to the beaker and we will observe that after we add water, the reaction will start spontaneously and instantly, and calcium hydroxide will be formed, which is also called as slaked lime. And if we touch the sides or the bottom of the beaker, we can feel the heat coming out of it. It's because it's an exothermic reaction. So the equation is calcium oxide plus water will give calcium hydroxide plus heat. As heat is radiating, it's an exothermic reaction. This experiment is about burning of ferrosulfate. The color of ferrosulfate is light green and the formula is FeSO4.7H2O. 7H2O is its water of crystallization as it is in its hydrated form. We will feed the test tube using a tongue and then heat it by using a Bunsen burner. Upon heating, we will find the occurrence of water droplets inside the test tube, which means the hydrated ferrosulfate is now converted into anhydrous form as its water of crystallization is now getting vaporized. Upon heating further, we will witness the change of color from light green to brown because here we have ferric oxide. alongside the emission of gases such as sulfur dioxide and sulfur trioxide. This is an example of decomposition reaction wherein one reactant will decompose, forming two or more products. This experiment is about the decomposition reaction of lead nitrate, which is PbNO3 Lead nitrate is white in color. We will collect it using a spatula in a test tube. You can adjust the amount according to your own needs. Then you will feed the test tube using a tongue and then heat it by using a Bunsen burner. You can directly heat the test tube without using tripod stand and wire gauze because this reaction will take a little longer, so using wire gauze can further delay the process. After you start heating it, you might hear some sound, but you have to keep heating it regardless. After a little time, the reaction will start and you can see a brown color gas being emitted out of it. It is because the decomposition reaction of lead nitrate into lead oxide plus nitrogen dioxide plus oxygen, and the brown color is because of the gas NO2, which is nitrogen dioxide. This experiment is about displacement reaction between iron and copper sulfate. First we will take two test tubes in a test tube stand and add water in equal amounts. Then we will take copper sulfate, which looks blue in color, and add it to both of the test tubes. For the experiment to be successful, we have to make sure that the intensity should match in both of the test tubes, and you can adjust the intensity based on the quantity you put in. Then we will take a clean polished iron nail, tie it to a thread for better handling in one of the test tube, and then leave it aside for some time. After some time, we will see that the iron nail, which was previously looking clean and polished, has now developed a brown color around it because of the reaction, which we can compare here. And the solution, which was originally looking blue in color, has now changed its color to green color. Here we can compare both of the test tubes. This is because of the reaction. In this reaction, iron has successfully displaced copper and has formed iron sulfate. This is a displacement reaction. This experiment is about the precipitation reaction between barium chloride and sodium sulfate. First, we will take two test tubes in a test tube stand and add water in equal amounts in both of these test tubes. Then we will take barium chloride, which has a white color powder form. We will collect it using a spatula and add it to the first test tube and then mix it to form a solution. Next, we will take sodium sulfate, which also has a white color powder form. We will collect it and add it to the second test tube and mix it to form a clear solution. And we will see that both of these test tubes are in transparent form and it doesn't have any texture. Then we will add sodium sulfate to barium chloride and see what happens. We will see that as soon as sodium sulfate is added to barium chloride, an instantaneous change will occur and the solution will form into a soapy foamy one, because here we have formed barium sulfate, which is a precipitate. After some time, precipitation will start and the precipitate will be accumulated at the bottom of the test tube and the supernatant will be separated from it. After keeping it for some time, we can clearly see the precipitate and supernatant. This experiment is about oxidation of copper into copper oxide. First, I will collect some of the copper powder in a china dish and then heat it by using a Bunsen burner. The color of copper powder is golden brown, and after heating it, we will observe the change of color into black. After heating it for some more time, we will see that the color has been completely changed into black color because here the reaction has been occurred and the copper in presence of oxygen has formed copper oxide, which is complete black in color. It's an example of oxidation reaction as well as an example of combination reaction.